Well, good morning, algebra. Here's the do now for today. You're going to solve one of these two inequalities. You can go ahead and count the number of letters in your first name. And if you come out with an odd amount of letters, do the green one, number one. If you come up with an even number of letters, then go ahead and do that purple one, number two. Hit pause till you got your solutions worked out, and then we'll rejoin. Well, welcome back. So here's what we got for the green one. I'm going to add 7. This is my opposite operation. Add 7 to both sides. Leaves me with 3x is greater than 12. Inequality symbol does not flip because I added. Next step is to divide by 3. And I got x is greater than 4. Again, my inequality symbol does not change because I'm dividing by positive 3. So no change to the inequality symbol. For the other one, there's only one step, but it's a little bit harder to recognize a lot of times. So that line stands for division. The opposite operation will be to multiply. So I got to multiply both sides of that inequality by 4. And again, my inequality symbol did not change. X is less than negative 8. So there was a negative number involved in multiplication this time, but we can't get tricked here. Our step that we did was multiplying by 4. 4 is a positive number, and when you multiply by a positive number, your inequality symbol does not change. So just because there's a negative number involved, don't let that fool you. Inequality symbol stays pointing the same direction it was before. All right, well, hidden down here below, I also had another question, which I went ahead and did, graphing the solution, both of those two solutions on the same number line. So x is greater than 4 in green, shows up at 4 with an open dot shading to the right. And the purple one, x is less than negative 8. I got my open dot at negative 8, and since it's less than, I shaded to the left. Cool. Well, today we are going to learn about solving compound inequalities. Our learning target is just that. You'll be able to solve compound inequalities. So last time we learned about compound inequalities, and we just did those first two tasks, writing them, graphing them. And so today we're going to pick it up where we left off, and we'll continue into solving. So remember, there are two types of inequalities. We introduced the words and the word or. Those become part of our number sentences. We got numbers, symbols, and words, but just those two words. They're the only ones that show up, and or. So a couple of examples. First one is an example of solving an or compound inequality. Although truth be told, it's the same approach you would use for a compound inequality that contained the word and. Now you remember, this is getting ahead of ourselves a little bit here, but and inequalities can be written in two different ways. One way includes the word, and the other way does not. Okay, so if it has the word and, you can do this same approach. All right, we're just going to take that inequality. Let's read it first. 3x minus 7 is greater than 5, or x divided by 4 is less than negative 2. And we're going to break it into two problems. That's what I said there for our directions. Break into two problems. So any place you see that word as part of our number sentence, that is the division point. So we got one inequality over here, we'll do in green. We got another inequality over here, we'll do in blue. And you just cut it right down the middle at the word or. We'll make two completely separate inequalities. So whatever steps we're going to take to solve the green one are totally unrelated to anything else in the problem. So I'll go ahead and cover it up. We don't need to see it right now. And if you're awake right now, you probably recognize this is the same problem we just did in the do now. So just add 7 to both sides. Ooh, these cancel. 3x is greater than 12. Divide by 3. And these 3's are going to cancel. X greater than and 4, just like we saw a minute ago. All right, and then here's the whole thing, but we're going to cover up all of this stuff all the way up through the word or. And the only thing we need to see here is just what I've highlighted in blue. The other part of the problem is irrelevant to what we're doing just for the next minute. So in order to solve this part, why am I working in green? It's the blue problem. I'm going to need to multiply both sides by 4 because that is the opposite operation. I'll see if I can get this to be a better color. Probably should be green. Not green. It should probably be blue to go with the blue highlighting. So multiply both sides by 4. These 4s are going to cancel each other. If I get my line to actually go through them, it'd be nice. And here's what will be left. X less than, this one is -8. Okay, so then we do have to bring these two pieces of the solution back together. And we do that by including that word or to combine those two parts of the solution into one compound solution. Okay, so the word compound, you might be familiar like from English class or something, compound words where you take two different words and you just bring them together, like break and dance, and you put them together to make break dance, right? It's the same kind of idea. You got green inequality and blue inequality. We just bring them together to create a compound inequality. It's like two separate inequalities that got attached, right? And so we have to attach our solution. All right. The second example is for solving a compound inequality that is of the type and, but is the alternate way of writing it where we don't actually use the word and. Instead of the word and, the alternate way to write a compound inequality for an and situation is to have two inequality symbols, which we have here. Here's one, here's two. And the x is in the center, right in between those two inequalities. So I'm going to highlight this whole part here. Okay, so let's read from start to finish. So let's read the inequality, and then we'll go back up to our steps. So -3 is less than or equal to 2x minus 1, which is less than or equal to 5. Okay, so in this case, do not separate the parts. We're not going to break it apart. Sometimes people try to do this. They'll be like, okay, I remember teacher said it's going to break this apart. And so I'm going to like cut it in half right down the center. All right. I mean, hey, you were paying attention. I said that. But you can't do it with this kind of inequality. So we're going to get rid of that. It's gone. Do not separate these. Instead, what we are going to do is I'm going to make some boundary lines below each of those inequality symbols. Okay, so it kind of is like there are 3 sections to this number sentence. Okay, we're not going to separate the sections, but I do want to mark them so that I can see where the sections are. I need to look at that middle section that I've highlighted in yellow. That's where the X shows up, and that is the only place where I'm going to look to find out what are my algebra steps I need to do. All right. So sometimes people get confused and they'll say, hey, there's a -3 over here. I'm going to start with that. So what would I need to do to cancel the -3? No, we don't care about the -3. In fact, I'm going to cover up both of these two outside numbers. Not permanently, but just for a second so that I can figure out what is it that I need to do right now. So I'm only going to focus on that part that is highlighted in yellow. That's where I look. I'm trying to get the X by itself. So I need to do the opposite operations to get that X by itself in the center portion. Okay, so my first step is going to be I need to do +1 to cancel that 1 out. Right, so I have created 3 sections in this inequality. I got like the left side, the center part, and the right side. I have to do the same step to all 3 sections. That's that third part of the directions up there. Do the same step to all 3 sections. So I'm looking in the middle to figure out what is my step, but now I'm going to have to do that step to all 3 parts. So now I am ready to move these things back out of the way so that I can actually do the problem with the numbers that are in here. All right, so these cancel. So let's start at the left side. -3 plus 1, that's -2. This next inequality symbol is not going to change. The 2x is going to come down. The next inequality symbol, I was loud, sorry about that. Next inequality symbol stays the same, and then 5 plus 1 is 6. All right, next step. Just to reiterate this idea, I'm going to go ahead and bring these 2 blocks down here and cover up these numbers because we never look at those outside numbers to figure out what we're supposed to do. The only place we ever look is right here in the center at the part that is highlighted in yellow. Okay, so my next step would be to do the opposite operation to cancel that 2, which means I have to divide. I'll have to divide by 2 in all of the different parts of my inequality, that number sentence. Okay, so now I can get rid of these things. I don't need those anymore. And okay, starting at the left-hand side, what column am I already? Okay, I got -2 divided by 2. That's going to be -1. This inequality symbol still does not change. I'm dividing by a positive number, right? Inequality symbols only change if I divide by a negative. Okay, these 2's cancel. X comes down. Inequality symbol comes down. And then over here on the right side, 6 divided by 2, that's 3. Here's my solution. X is between -1 and 3. Okay, it's an and situation, just like remember we described the ages of teenagers. The age of a person has to be between, the lower limit and the upper limit, whatever numbers we agreed on, 13 and 19 or 13 and 17 or whatever, right? So same kind of thing here. The X is between -1 on one end, +3 on the other end. And when we graph something like this, we're going to graph it to look exactly like what that number sentence looks like. This number and that inequality symbol go together. So on the -1, I'm going to use that symbol to tell me what kind of dot I should use. It's got the or equal to as part of its name. And so I'd use a closed dot on the -1. This inequality symbol and number go together. And so on the 3, I'm going to put a closed dot also because that inequality symbol has an or equal to as part of its name. And then I shade the part that is between those 2 dots from -1 up to 3. And that is an and compound inequality.